I love poo. And hopefully by the end of my talk, you guys will love it too. So there are 100 trillion microbial cells that reside in the human body, meaning we are more microbe than we are human. These microbes are known as the human microbiome, or microbiota, a collection of microbial cells that have co-evolved with us over millennia and now play an important role in our physiology, influencing everything from our metabolism to our immune system, neurotransmitters, neonatal development, and potentially more than we can even imagine. These microbes begin colonizing us during the neonatal period, and this actually helps to drive infant development. However, when this colonization process is disrupted, like in those babies born prematurely, the microbiome can become dysbiotic or out of balance, meaning there are fewer good microbes and more bad microbes, as well as lower diversity. And unfortunately for these premature babies, this puts them at a greater risk of acute infection, chronic disease, and developmental abnormalities. So with this in mind, for my PhD, I decided to collect some poo. Some baby poo. Baby poo from premature babies at the Townsville Hospital. And I know it sounds kind of crappy, but by collecting poo, extracting microbial DNA from said poo, and sequencing it, we can identify the microbes in that poo. And then the microbes in that poo paint an accurate picture of the microbial populations that exist in the guts of these babies. So it's my hope that what we find in this poo may one day guide intervention, leading to better health outcomes for these little poo machines. And so what have we found so far? Well, for the most part, the same as everybody else, but with one very interesting exception. Our younger, more fragile babies have a microbiome that is both higher in diversity and higher in abundance of good microbes. Now, this is interesting because lower gestational age is usually associated with the microbiome that is lower in diversity and lower in abundance of these same good microbes. So why are we seeing the complete opposite? Well, one potential explanation is probiotics, or supplements containing live microorganisms that contribute to a healthy microbial environment. And probiotics, in this case containing these same good microbes, are given to all of our younger infants at the Townsville Hospital as part of standard care, but not to their older counterparts. So this then begs the question, if these older premature babies are still at a high risk of diseases and disorders, and their younger, theoretically higher risk counterparts appear to have a healthier microbiome, then should these older babies also be receiving probiotics? But to answer that, folks, I'm going to need some more poo. So thank you.